Of course, to safely fly a Baron, you need to practice flying it on one engine. The highlight of BPPP instruction for many pilots is an actual engine shutdown in flight under the guidance of a Baron expert instructor. After ensuring your engine has cooled sufficiently, your instructor will simulate an engine failure by retarding a throttle slowly to idle. You'll fly the airplane while completing the engine failure in flight procedure, including feathering the propeller. As you maneuver in single-engine flight, you'll experience the effect of rudder, aileron, and pitch on single-engine performance. You'll practice making shallow bank turns to see how even small bank angles result in a reduction of the airplane's performance on one engine. The Baron is very controllable and capable on one engine, but it takes precise control inputs to get maximum single-engine performance out of your Baron. Unlike what you've been taught for almost every other flight condition, with an engine out, you do not want the slip-skid ball centered. Wings level, ball-centered flight will result in a slip toward the inoperative engine. The airplane will yaw and create extra drag by exposing the side of the fuselage to the slipstream. Instead, to point directly into the relative wind for least drag and maximum single-engine performance, it takes a slight bank and rudder into the good engine to balance the rudder force and align the airplane into the relative wind. The precise angle of bank required is dependent on the amount of rudder needed to counteract asymmetric thrust, and the amount of rudder required is dependent on how much power the operating engine is developing. In general, best results come with a very slight bank into the good engine. Flight test data, using a Baron 58 at 6,000 feet, determined that zero side slip comes by banking 2.7 degrees into the good engine, with the slip skid ball deflected 1/3 to 1/2 the ball's diameter toward the good engine. Under the conditions tested, the maximum single-engine rate of climb was 150 feet per minute. Using 5 degrees of bank under these circumstances resulted in only 50 feet per minute climb rate. This chart also illustrates the effect on vertical speed when you turn the airplane in single-engine flight. Even a half-standard rate turn, about 7 degrees of bank at blue line speed, will prevent the airplane from being able to climb. The lesson here is that if you lose an engine shortly after takeoff, you should climb to a safe altitude on one engine first and then bank to return to the airport. There are several other variables that affect single-engine performance. Extending the landing gear or failing to feather the propeller will reduce the maximum available single-engine climb rate by about 800 feet per minute. Given that under the best circumstances, single-engine climb performance is about half that amount, you can see why it's so important to be gear up with the propeller feathered if you try to climb on one engine. For a given set of conditions, each 1,000 feet of increase in altitude reduces maximum single-engine climb performance by 40 feet per minute. Another factor is airplane weight. Maximum single-engine climb potential improves by 40 feet per minute for every 100 pounds below maximum certificated weight. Now that you've learned how to get maximum single-engine performance from your Baron, you'll perform the air start procedure and gradually warm your engine back up to resume two-engine flight. During flight, or in your post-flight debrief, you'll discuss making a single-engine landing. As you reduce power on the good engine, you'll notice the thrust vectors are reversed. The feathered propeller has less drag than the idling propeller on the good engine. This means you will have to bank into the dead engine to maintain runway alignment in a single-engine landing. Landing on one engine means you'll have about half the propeller drag. Expect the airplane to float much farther in the flare and to land long. When faced with a single-engine landing, aim for the longest available runway aligned with the wind. What if you see the need to make a single-engine go-around? Maintaining control while powering up to climb out on one engine is very demanding. The airplane will go from a condition of low asymmetric thrust to high asymmetric thrust in a very short period of time. You'll need to make rapid, deliberate control inputs on the rudder, aileron, and elevator to maintain speed and control. It is very much like losing an engine immediately after takeoff, with wheels down and probably at least partial flaps as well. Evaluate the need for a single engine go-around early. Even done expertly, you will lose 400 feet or more in the transition from a draggy single-engine descent to a clean single-engine climb-out at blue line speed. If the airplane is below blue line airspeed, you're less than 500 feet above ground level, or if you've already extended full flaps, you're committed to land. From any of these conditions, you can't reverse the vertical speed trend, increase airspeed, or reduce drag quickly enough to permit turning a descent into a single-engine climb. If conditions permit a single-engine go-around, you'll reintroduce the yaw, roll, and pitch changes from asymmetric thrust when you add power on the good engine. Don't wait for a positive rate of climb before retracting the landing gear. It's probably not possible to attain positive rate with the gear down in this configuration. Focus on precise attitude control to maintain blue line speed. Going any faster or slower puts making a successful go-around seriously in doubt. You may have to level off briefly to let airspeed build back up to blue line. Retract approach flaps if they were extended, adjusting pitch and trim as necessary to return to a 7-degree nose-up attitude with zero side-slip bank and rudder control. Now you face the same need to climb straight ahead before making any turns that you face if an engine fails immediately after gear retraction on takeoff. You can see that best results come from planning ahead for your one-engine landing, so you do not need to attempt a single-engine go-around. Before your Baron checkout is complete, you will also practice the manual landing gear extension procedure. You'll experience what happens if the forward cabin door pops open in flight, and learn that the airplane handling is virtually unchanged, permitting a normal landing. Any checkout includes a series of normal, crosswind, and maximum performance takeoffs and landings. And if you're instrument rated, you should complete all required items for an instrument procedures check, so you're very familiar with Baron-specific instrument procedures before you launch into IFR conditions. This program has just touched on the highlights of what you need to learn in a good Baron checkout. There is a great deal more you'll learn when you fly with an experienced BPPP instructor, who will point out the differences for the specific model of Baron you fly. The American Bonanza Society provides the pilot training and aircraft maintenance resources you need to be a capable and confident Baron pilot, and to keep your Beechcraft well supported and safe. Although our name might suggest otherwise, we are also the Baron Owners Society. Contact ABS at www.bonanza.org or through their resources documents in this ABS Sporty's Pilot Shop presentation. Thank you for making the extra effort to be an even safer Baron pilot.